Over here you'll see a mathematical expression. We know it's an expression because it doesn't have an equal sign. But what I want to know is this. What does the 2 mean? In this lesson we're going to be looking at the parts of an expression. That means we're going to be learning a lot of vocab that's going to let us describe what's going on in an expression. And that vocabulary includes the words coefficient, variable, exponent, term, linear term, and constant term. And we're going to have to know what all those mean and how we can use them to describe a linear expression. So back to 5x squared plus 3x plus 2. I ask you to describe for me what the 2 meant. But the problem is there are 2 2's. So in order for you to tell me what the 2 means, not only do you have to know what all these numbers mean, but you also have to know which 2 I'm talking about. It could be that one or it could be that one, and I was not real clear as to which one you were supposed to talk about. So it almost doesn't matter what your answer was. What I really wanted you to see was that because there are 2 of the number 2's in this expression, I have to describe which 2 I mean. And we could say something like, oh, the 2 on the left and the 2 on the right. However, if I have a whole bunch of 2's, that doesn't really help me. So what we need to do is we need to learn how to describe all these different parts. And we're going to start with a variable. So a variable is just a letter that's used to represent an unknown number. We don't know what the number is, so rather than not know what the number is and have to write, this is the number I don't know, over and over again, we use a shorthand for it, a variable, a letter. If math is a language, and it is, you can think of variables as being the pronouns. The pronoun I refers to whoever the speaker is. So rather than having to say your name over and over again, you can just say I, and it shortens it. Whoever you're speaking to, we call you. Rather than having to give that person's name over and over again, we just use the word you as a substitute. Variables are the same way. So we have 2 variables in this expression. We have x and x squared. And notice that this piece up here gets included as being part of the variable. These would be considered 2 different variables. Pardon my terrible arrow there. Let's fix that a little bit. These would be 2 separate variables. X squared is its own variable, and x is its own variable. And they're just shorthands to represent some number. For instance, this could represent 4, and this could represent 2. We don't know. It could be anything. But these represent 2 separate values. We also have these things that are called coefficients. And there are 2 coefficients in this. In fact, let me do something a little more clear. We've got a coefficient right there and a coefficient right there. Coefficients are numbers written in front of variables, and what this means is to take that number and multiply it by the variable. So this coefficient of 3 with the x, this literally means 3 times x. This 5 in front of the x squared means 5 times x squared. Now I included the plus sign with this 3 because when we're looking at the coefficient, the sign of the coefficient is whatever's in front of it. So this is a positive 3x. Were this a minus sign, we would consider the coefficient to be negative 3. We can also have these things called exponents. And these can be written over numbers or variables, either one. And it's written as what's called a superscript. Super means above. For example, Superman is much greater than a normal man. He's above a normal man. So a superscript is written above all the other words. Script just meaning letter there. And this superscript indicates growth of this variable. And we're not going to go very far down that. All you have to know is that if you see something written above the line like that as a superscript, it's what we call an exponent. And if it is attached to the variable, it is considered to be part of the variable. We also have these things called terms. And this is a little bit harder to describe, or a little bit harder to get your mind around. Terms are parts of an expression, and they're separated from the other parts of the expression by plus or minus signs. In this particular expression, we have three terms. We have the 5x squared, which is one term, and then we have the plus 3x, which is another term, and the plus 2, which is yet another term. So 5x squared plus 3x plus 2, three different terms. You can see there are two plus signs here. And if I think of each plus or minus sign as being a wall, I can see that wall divides this into three separate sections. Each one of those sections is called a term. And so if I need to identify the 3x, I would say that's the second term. It's the term that comes second when you go left to right. Again, this could be minus signs separating these. They don't have to be plus, but within a term, I can multiply or divide or use exponents all I want, but as soon as I add or subtract, I'm talking about another term. And whilst talking about other terms, I have two descriptions for them. I can have a linear term or a constant term. Now, we're not going to worry about terms that have variables, but for right now, we're going to worry about a linear term as a term that has just one variable, and that variable has no exponent. So if we look at this, we have three terms in this expression. This term has a variable, so it's not a linear term. This term doesn't even have a variable, not a linear term. This one, however, it has one variable, and that variable has no exponent. So we would say that this term right here is in fact a linear term. The other thing we want to know about a term is it a constant term? A constant term is a term that doesn't have a variable. So again, I have three terms, 5x squared, 3x plus 2, and if it's constant, it won't have a variable. That's not a constant term. That's not a constant term. That is, because it does not have a variable. So we would say that this plus 2 is my constant term. And now if we think about going back to our original dilemma that we had, where I ask you to describe the two, we can see now how much easier it would be to point out which two I'm talking about. Knowing this vocabulary, I can say, what does the constant term of 2 mean? And now you know that I mean that 2 right there. Or I can ask you, what does the exponent 2 mean in the first term? And now I know I'm looking for an exponent 2. I know how to identify the first term. And so using all of those words, I can very clearly describe where things are in a given expression, which is why it's so important that we learn this vocabulary. So to recap, we have all these terms: variables, coefficients, terms, exponents, linear terms, constant terms, and let's see if we can't take these and kind of identify the parts out of this. So for variables, we have x squared, that's a variable, and we have x, that's a variable. So those right there would be variables. Coefficients, let me change colors so we can see this more clearly. Coefficients are the numbers in front of the variables that are getting multiplied. So we have two coefficients there, the numbers in front of the variables. And then for terms, terms are those things separated by plus signs or minus signs. So we have, think of a wall there and a wall there. So I have three terms, one right there, one right there, and one right there, and I've succeeded in making the messiest diagram that ever did exist. So we have variables, the letters that represent numbers. We have coefficients, the numbers in front of the variables that are being multiplied by the variables, and terms are the individual parts of the expression separated by addition or subtraction signs. We can also have these things that we call exponents. Exponents are little superscript numbers that represent growth. They can be written above either variables or constant terms, so I can just put them on a number. We're not going to worry about them past identifying that, hey, these exist. Linear terms. A linear term has one single variable with no exponent. So 3x right there would be our linear term. Our constant term is a term that has no variable in it whatsoever. Boom, right there, our 2. And so that would be our constant term.